Okay, lecture 53, thermochemical equations. This is just a quick look at the basics that we're going to be using for Hess's law and for some other calculations down the line. This type of problem is given in words and we have to write out the equation. So when 2 moles of sodium chlorite decomposes into sodium chloride and oxygen, 116 kilojoules of heat is given off. Write a thermochemical equation for this reaction. So we have 2 moles of sodium chlorate, and on the exam too you'd be given the phases, but it's solid and goes to sodium chloride. I'm just going to balance as I go, since I can pretty much guess what this is. And then oxygen is O2, so that should be 3, and that should be a gas. And they say 116 kilojoules of energy is given off, so delta H, put a semicolon in here, so delta H is minus 116 kilojoules for this reaction. So just writing it off, so 2 moles, yeah, looks good. Now, multiply the above thermochemical equation through by 3. It happens sometimes that we want to take a balanced equation that has the lowest ratio of whole numbers, and we want to multiply through, either making the numbers larger or smaller. We could certainly multiply through by 1/3 if we wanted to, or 1/7. Depends on, there's different reasons for doing that, so we should know how to deal with that. So let me try to get both on here. So if we have to multiply through by 3, then it's going to be 2 times 3, so that'll be 6. 2 times 3, or 3 times 2 there is 6 again. And then 3 times 3, so that's going to be 9. Well, since we've tripled the amount of substance or number of species on both sides, that means that the heat given off must be increased by 3. Now, you can certainly follow that rule, but you got to think about what we're doing here. By multiplying through by 3, we've tripled the amount of sodium chlorate. Since we tripled the amount of sodium chlorate that decomposes, we should get 3 times as much heat. If we multiply this through by 27, we should multiply this number by 27. We divide these numbers through everything by 250. This gets divided through by 250. Now, the main thing here is when you do that, you have to multiply every single coefficient by the same number, and that number is what you multiply the delta H by. Then they say reverse the thermochemical equation from number 2. Yeah, which means we just flip it around. In the next semester, you'll learn that all reactions are reversible, and so it's fine to do this. It seems kind of weird to do this right now, but in this case, we're doing it because it's going to be helpful for another problem we have to deal with. When you flip a reaction around, then the sign has to change on delta H. If it's negative, make it positive. If it's positive, it's negative. What that means is that instead of going from sodium chlorate to its sodium chloride and oxygen, we're putting them back together. So the heat that was given off is essentially, by flipping around, means that we've put the heat back into the system to bring these guys back together into the original reactants. So multiply through by a number, delta H gets multiplied by the same number. Flip the reaction around, change the sign. Positive goes to negative, negative goes to positive.